Hello everyone, welcome back to Engineering Graphics YouTube channel. I am Professor Swapnil and today's lecture we are starting one of the most fundamental topic of engineering graphics, and the name of the topic is engineering curve. Understanding these curves are extremely important because they form the basis for the design of many mechanical parts like cams, linkages, gears, and many more. In today's session, we will cover the what are the engineering curves, types of engineering curves, and how to draw few basic curves step by step. So what are the engineering curves? Engineering curves are the smooth, continuous shapes that are mathematically defined and widely used in engineering designs and mechanical components. They are different from the straight line and circle because they have more complex, precise shapes. The most commonly studied curves are ellipse, parabola, hyperbola, cycloid, involute, spiral, helix. So let's understand the procedure to draw ellipse curve. An ellipse looks like a flattened circle. There are multiple methods to draw an ellipse. The first method is focus directrix method and second method name is rectangle method or oblong method. By using these two methods, we can draw ellipse, parabola, hyperbola. In today's session, we will learn the focus directrix method, and by using this method, we will draw ellipse, parabola, and hyperbola. So for focus directrix method, we required some different terms. You can see here the focus. Focus is the fixed point. Focus is the fixed point is marked on an axis. Axis, you can see here the horizontal straight line is called as axis. The line passing through the focus is called as axis. Directrix, the vertical fixed line is called as directrix. Directrix and axis meets at a point C. Now the V is a vertex point and it is defined as the point at which the curve intersects the axis is called vertex. Now, the ellipse, parabola, hyperbola we can draw with the help of focus directrix method and rectangular method. For focus directrix method, we required eccentricity ratio E. Eccentricity ratio eccentricity ratio is the ratio of distance of a point from focus. Distance of a point from focus, it is nothing but V of distance divided by distance of a point from directrix. Now eccentricity is a ratio of V of distance divided by VC distance. This eccentricity decides the type of curve. If the eccentricity is greater than 1, at that time hyperbola curve is formed. When the eccentricity equal to 1, at that time parabola curve is formed. And when eccentricity is less than 1, then ellipse curve is formed. Now you can see here the ellipse curve. This is the ellipse curve have two vertex point V and V1. The two focus point. For parabola we will get one vertex point. For hyperbola we will get one vertex point. So for focus directrix method we required directrix, axis, focus and vertex, as well as we required eccentricity. So let's start problem on ellipse. Now you can see here the problem statement. Draw an ellipse when the distance of focus from the directrix is equal to 60 mm and eccentricity is 2 by 3. Solution for this problem. Now for this problem, the distance of focus from the directrix is given. It is 60 mm. So we know that the directrix is a vertical line. It is noted by D, D dash or D, D1. So C is the intersection point of axis and directrix. On this axis, the focus point is there and vertex point is there. And eccentricity is a ratio of V of distance divided by VC distance. Here, the distance of focus from the directrix is given. So C of distance is given. It is 60 mm. And eccentricity ratio is given 2 by 3. We know that eccentricity is equal to V of divided by VC. So we required V of as a 2 part and VC is a 3 part. So to divide the 60 mm C of distance into 5 equal segments, 5 equal divisions. So 60 divided by 5 is nothing but 12. So V of distance we required 24 and VC distance is required 36. 12 2s are 24, 12 3s are 36. Okay. So we required V of is a 24 mm and VC is required 36 mm. So we will draw directrix and axis. First we will draw a vertical line is called as directrix. then draw a perpendicular line to the directrix is called as axis. So the name of the vertical line is D dash or D1. The intersection point of axis and directrix is called as C. You can see here the C. Now mark a point or divide CF into 5 equal segments. Now take 12 mm distance in your compass. And mark a 5 equal divisions. You can see here 1, 2, 3, 4, 5. We required VF as a 24 or 2 part, and VC required 3 part. This is 2 part and this is 3 part. So here we will get a vertex point V. So we have marked the vertex V after 2 division from the focus, and eccentricity is maintained as a 2:3. Draw a line. Now the next step, draw a perpendicular line to the axis which is passing through vertex V. Draw an arc. Draw an arc. This is your focus point F. This is focus point F. Now take VF as a radius, V as a center, and mark a arc up to this vertical line. So here we will get a point A. Join CA, long line. Now from F point, mark 45-degree angle. This is 45 degree. These two lines intersect at a point B. From B, draw the vertical line up to axis. This is V point, this is V point. These are the two vertex points of a ellipse. This is a major axis of a ellipse. Now divide V1, V and V1 into multiple segments. Approximate. Mark point 1, 1, 2, so mark point 1 to 9, 1 to 10 approximately on a line V1. Through these points, draw the perpendicular line to axis. So adjust a ruler and draw the perpendicular line which intersect the line to CAB. Follow the same procedure. Adjust a ruler along axis and draw this line as a thin line. You can give the name of this line 1, 2, 3, 4, 5, 6, 9. Okay. Now take a 1 distance in your compass and F as a center, and cut the arc on a perpendicular line. Now you can see here we have taken 1 distance, take as a F as a center and mark a arc on 1 line above the axis, below the axis. Take 2 dash distance. Here I get a point 2. So this is your point P1 dash. Here I get a point P1. This is P2 dash. Same point you will get. This is P2. Take 3 distance in your compass. Take F as a center. Mark a small arc. This is P3 dash, P3. Now take 4 dash distance in your compass. Follow the same procedure. Take 5 dash distance. Take F as the center. 6 dash. 7 distance. Take F as the center. Take 8 dash distance. 9 dash distance. You can see we'll get different points. This is P4 dash, P5 dash, P6 dash, P7 dash, P8 dash, P9 dash. This is endpoint. This is P9, P8, P7, P6, P5, P4. Join all these points by using smooth curve. You can join all these points by using French curve or a freehand curve. Follow the same procedure for so we will get a ellipse curve. So this method is called as directrix focus method. Thank you for watching this video.